Hey, welcome everybody to our presentation by Professor Margaret Burnett, our Distinguished Professor of Electrical Engineering and Computer Science. She is one of two Oregon State University faculty members to be awarded the title of Distinguished Professor this year. It's the highest honor that OSU gives its faculty for pioneering leadership and outstanding contributions to visual programming languages, end-user software engineering, and gender-inclusive software. Margaret is one of the pioneers for women in STEM, with her accomplishments dating back to 1971, where she was the first woman ever to be hired in a management position at Procter & Gamble's Ivory Dale complex. In 1991, she was the second woman to get her PhD in computer science at the University of Kansas. And in 1992, she and our Sherry Pancake were the first women ever hired by OSU in computer science and tenure-track positions. Her work in gender-inclusive software development is in line with her leadership in several gender diversity issues and activities here on campus, as well as nationally. Professor Burnett's work systematically debunked the misconceptions of neutrality in gender-neutral software. Her work has received wide attention in the popular press, CNN, CBS, Chicago Tribune, USA Today, as well as within the research community. And she's given invited talks on this topic in 8 different languages, as well as across the United States.
That's countries, not languages. Just so you know.
It's okay. Languages. I mean countries. So with all these, actually this will come to my personal comments here in a minute. So with all of these extraordinary accomplishments, Margaret shared with us that the first thing that she finds most rewarding about her job is when she is working with a student enables them to be the very best that they can be. And I will say that on a personal note, I'm greatly appreciate Margaret's willingness to give me input and insight on how I'm doing and how the college is doing. And really, if I look at over the last couple of years as being dean, she has changed me and the college for the better, and I greatly appreciate it. So the way that we will work today, this is a streaming event. We also get questions. And at the end of the talk, if anybody in the audience has questions here, please come up to the microphones and you can entertain as many as you like. If questions come in online, then Andrea will come up to the microphone and give Margaret those questions as well. So with that, it is my distinct pleasure to introduce to you Margaret Burnett, the 2016 Distinguished Professor of Electrical Engineering and Computer Science.
Thank you, Scott. Well, thank you all for coming. I'm tremendously honored to have received this award. It really surprised me a lot. So I'm really thrilled. And to help commemorate it today, on my way in, I thought, gee, I need to do something a little different for this talk. So I bought a beaver scarf. Do you like the beaver scarf? Put it on my way here. So I'm very honored to have the opportunity also to talk to you about something that's been a passion of mine for over a decade now, and that's women and software itself. So this isn't about women and the workplace or women in the education environment, this particular research. This is about me and the computer experiences from a gender perspective. Let's start, though, with just a tiny little bit about me. So I've been working on people aspects of software development forever, and Scott talked about a few of those. The one, of course, that I'll be talking about today is just the gender-inclusive software thread. A few of my professional highs, as Scott mentioned, I was the first woman software developer, as well as the first woman manager in Procter & Gamble Ivory Dale, so that was an interesting start to a career. There were a variety of kind of startups and degrees along the way, and then ultimately I ended up in academia. I've been lucky enough to win some mentoring awards, and one of them was for helping to write that book. Let's see, how's my mouse doing? Can you see it? Yeah, kind of, sort of. That book, which is, well, it's not a book, it's a kit. It's freely downloadable. So if you happen to be a faculty member or a scientist or an engineer in the audience and you happen to want to know how to work with research undergraduate students, you can download that. I've also been lucky enough to get some awards from my profession in research, including ACM Distinguished Scientist and the ACM Chi Academy. Those are professional associations in the computer science community. But the thing that I get the most pleasure out of is making a difference, both at a small level and a big level. I'm happy to say that this person isn't in the audience today. I was a little afraid she might be embarrassed if she saw it, but she's not, so okay. This was a high school researcher who worked for me, and at the end of their high school internships, they have to write a little report. And one of the things they have to say is, what was the thing that stood out for you the most? And she said, the moment that stood out the most for me was Dr. Burnett saying she was interested in working with me in the future. So just making a tiny little difference to one person with one sentence, this like makes your year. So yeah, that's the kind of thing that I get a huge high out of, as well as making a difference to the larger community. Here's a picture of my personal highs. These are my adorable grandchildren. Okay, so on to the topic at hand, gender-inclusive software. So the question is, does software support a variety of users, a variety of smart users? So there's a smart user right there. Where is my mouse? There we are, right there. And software tends to support him. But I have years of research that shows that it doesn't tend to support a lot of other kinds of smart users. So there are lots and lots of other sorts of smart users, and the problem is that because of unconscious biases, a lot of times software is written around assumptions that support mainly one kind of user. So what I've been doing, along with a lot of collaborators and students, is to try to raise awareness of the unconscious biases that affect software. And so this research has been kind of made concrete by some recent work that we've done in a process called GenderMag. And so GenderMag is in beta and an emerging thing, but it helps make everything concrete. So I'm going to use that as my vehicle to help you understand these gender differences that can play out in software. But some of you may say, oh gosh, I don't even know if I care. So here is one reason why somebody might care, and that's the economics behind it. So women drive 70 to 80% of consumer purchasing these days. This comes from Forbes magazine, a fairly recent issue. And furthermore, as the Harvard Business Review points out, women are the largest emerging market right now. They're more than twice, their income is more than twice the size of China plus India's GDP combined, okay? So if people are looking for emerging markets, start with right here at home. Furthermore, women have multiplier effects. So it's not just their income that they're spending, which is what you saw in the previous graph, because in most societies, they tend to be the primary caregivers. And so this means that they also spend other members of their family's money on the other members of the family. So in other words, they buy on behalf of people who live with them. So it's an even bigger emerging market than the one that I just showed. Okay, but there are other reasons. You don't have to be swayed by economics and good business. Reason number 2 is basically that ignorance is not bliss. So those of us who are education and academia inclined, this one may resonate more with us. And so one possibility might be to say, well, I'm a little afraid of thinking about gender differences and how that might come together with software. I might be perceived as being politically incorrect or biased or who knows what. And so I won't. I'll just keep trying to do good stuff. But the trouble is, this is the way unwitting barriers come about. Unwitting, okay? Ignorance is not bliss. And we have a great example of that in computer science itself. So in computer science itself, we've always had a shortage of women. And so have some of the other engineering and technical fields. But the other engineering and technical fields are getting better. We alone have the distinction of getting worse, okay? And so we're doing a lot worse than every other technical STEM field you can imagine. And there are a lot of factors behind that, and I won't claim that computer science education is the only one, but we're part of it because we've been teaching computer science in a traditionally male-oriented way. And it took us years to notice that. And when we finally did, trying to undo the damage of decades, I mean, that's hard work, and we're still working very hard at it. So that was reason number 2. Reason number 3, it's been well acknowledged in the design community that when you study one population segment, you can see things sometimes that you never would have seen before, and they can help everyone. And a classic example of that is curb cuts. So there's a picture of a curb cut, and that's that sort of cut-out place in the sidewalk, right? Way back in the old days, there were no curb cuts, and somebody noticed people like this in wheelchairs having to deal with the lack of curb cuts. And they said, oh my gosh, this is terrible, we have to do something, and curb cuts were born. Curb cuts were born. And they did help people in wheelchairs. And they helped people with those walkers with wheels on them, too. And they helped mothers pushing strollers. And they helped people on bicycles. And they helped people pushing heavy bales of hay with their dollies. And they help the few people in the world that have those suitcases with wheels on them, okay? Now, if we had been looking at sidewalks from a sort of everybody perspective, I doubt that we would have invented curb cuts. But look what happens when we look closely at one underserved segment of the population. Sidewalks got better for everyone. Here's reason number 4. The target customers. This is kind of related to economics, but it's much more concrete. This is a critical email that I got, and this is the thing that actually kicked off our transition from just doing research about gender-inclusive software to coming up with a practical process that other people could use. So I got this email from a software product manager whose name is not John, who works at a company that's not called Company X. And that company makes software for this one branch of medicine, in which the way they prescribe things is they write these programs. And so what they're trying to do is they're trying to tailor a particular medical device to the particular needs of one patient. And so they do that with software. That's how they do it. And they do that for each individual patient. That's their way of doing a prescription. Well, the problem for that company is that 85% of that branch of the medical profession is female. That's not a problem. But the problem for this company is the females did not like their software. And so this was a big problem. I mean, that's who they're selling to. And the development team, which happened to be all males, not too surprising, didn't know why or what to change. But I maintain that even if there had been females on that development team there, they still might not have known, because there's a lot of inertia about the way software has always been and how it should be. In any case, they didn't know what to do, and so they contacted me and said, help, what do I do? And that's what started us to come up with this practical process. So what I hope is that by now, everybody in the room is saying, okay, you got me. With one of these reasons, I care. But how? How do I do this? Other people have said, I care without the how part, and so here's a phenomenally awful strategy. Shrink it and pink it, okay? You've maybe seen these. Actually, that's a real phrase. You can look it up. You'll find it. Shrink it and pink it. Here's a great example. So the Dell pink laptop, this was such an embarrassment to them. I don't know what they were thinking. It's true that there are some females, obviously a sizable amount of their population, that weren't thrilled with their computers, so they said, oh, I know how to fix this. We'll make them pink. So that was horrible. They issued apologies. They took down their, Della website is what it was called. Oh, yeah, it's great. Okay. Here's another really famous one, Bic for Her. Oh my goodness, you should Google that one. You've seen that? Where people are talking about my feeble little hands. I've never been able to deal with ink pens before, but now finally, okay, there's Bic for Her. It's just to enable you to see that label. Yes, it's for her, and it's pink and stylish. Yeah, they got into a lot of trouble for that. So why are these things wrong? What's really wrong with this strategy? Well, what it's saying is, oh yeah, we do want your money. And here's a really surface level gesture that shows that we really don't care at all about what you might really need. We don't want to think about you. We just want your money. So this is not a really great way to build up customer loyalty, and so that's what's wrong with that. So then what should you do? Well, if you're a man, what you should do is this. You should listen to and research women as though they were a foreign market. And why would we say that as though they're a foreign market? It's because the reason foreign markets have to be studied is they have a culture. They all have their cultures. Well, people grow up within the cultures of their genders as well. And so it has to be studied and investigated. And so if you're a man, you just have to understand you know nothing, okay? And certainly you don't know that all women like pink. So start listening, and paying attention. If you're a woman, what should you do? Exactly the same thing. Because it turns out that within gender, people are more different than they are alike, okay? So even if you're a woman, you don't know what women like. What if you're some non-traditional gender? Well, you probably already know this lesson better than anyone, okay? People are more different within a gender than they are alike, so you too have to do this the same way. So then what is it that we're understanding just from this much? Gender inclusiveness needs to be about inclusiveness, okay? It can't be about typical females and males because there aren't any. Okay, so here we come to the rescue, the GenderMag method. This GenderMag stands for Gender Inclusiveness Magnifier, and it's a way to try to get to gender-inclusive software. It's a way for the software industry, anybody who develops software, to evaluate their software's inclusiveness through this lens. The scope, the setting, is when the software's user is problem solving. So let me give you some examples. Suppose you're an accountant or an office worker or a manager, and you're saying, why doesn't my budget balance? And typically you're sitting in front of a spreadsheet and you're working with things and you're scratching your head and you're going, how, why, okay? That's problem solving, and that's a good place to be using the Gender Inclusiveness Magnifier to find out whether you're being inclusive in supporting everybody's different styles of going about that. Another great example is debugging tools. So if you are debugging your own software, you're a software developer, and you're going, how, why, that's problem solving. This is a good fit for GenderMag. Decision support systems. If you're, say, physically challenged or in a new environment and you're trying to find out a good public transportation route to get from A to B. Any of these problem-solving settings are good fits for this. And here's one more. All of those were about software that's supposed to help you solve problems. Well, then sometimes you're using software that's not about problem solving at all, right? But its user interface is so obtuse. What are you saying? How? Why? Okay? You're still problem solving. So that's a great mix, a great fit for GenderMag too. All right, so that's the situation that it's good at. In order to accomplish that, GenderMag has these 5 personas, which I'll explain to you in a minute, that are based on 5 gender inclusiveness facets, which I'll also explain to you in a minute, and then a process that embeds those facets and personas into a set of steps. Okay, oh, there's a picture of my personas. All right, so what is a persona? If you're in computer science or perhaps marketing, a few areas like that, you may have heard of these things. A persona is a representative of a slice of the user population that you care about. Not of everybody, but you just pick some slice and you come up with this representative. The GenderMag personas are like that, but only from the perspective of these 5 problem-solving facets. And you don't have to memorize this list because I'm going to explain them all to you. We have 4 personas that capture different values that these facets might take. So I'm going to use Abby to introduce these to you. Don't try to read this. The font is really tiny, okay? I don't want you to read it, but I do want you to notice that Abby fits on one page, okay? So she's pretty practical. Okay, the next thing I want you to notice is I've just stuck a line into about the middle of Abby. The part above the line, people can tailor for their own target audience. And so like if they're building software for runners, then instead of Abby being an accountant, she can be a runner. And she can be different ages, she can have different pictures, she can live in different places. The part below the line is all based on research. You can't change a word of that, okay? Because that's what makes these things valid. And all of that part below the line is really thoroughly based in a lot of research, which you'll see tiny little pieces of as I go through this. So there's the picture that comes with Abby, but we also have 3 other pictures that you can choose instead, or you can just make up your own. So here's a younger Abby that happens to be of a different ethnic group. Here's a male Abby who also happens to be of a different socioeconomic group, and by the way, if you use him, you should call him Abe. Or you can call him Abe, and here's an older Abby. So any of these Abbies are valid for the way we've written this persona. Okay, so what are these facets and how do they look in the persona? This you're allowed to read because look, nice big print, that's how you can tell. Facet number 1, computer self-efficacy. So Abby is proficient with the technology she uses. She's good at the stuff she uses every day, but she has low computer self-efficacy, which means she has low self-confidence in performing new computing tasks. And if she runs into problems, she tends to blame herself. So what is this computer self-efficacy, and where did I get this? Where did we get this? Self-efficacy is a really well-established theory from psychology, goes all the way back to Bandura in the early 70s. It is a form of self-confidence that is regarding a specific upcoming task. So you might have high bike riding self-efficacy and low cooking self-efficacy and so on and so forth. It's a general theory, and it's been shown quite resoundingly over and over again that low self-efficacy in some area is really predictive of whether or not you're going to be willing to try in the first place, and if the going gets tough, whether or not you're going to be willing to persevere, whether you'll be willing to try different strategies. It has a huge impact on whether or not you can succeed regardless of your skills, okay? And the literature resoundingly shows that statistically, females have lower computer self-efficacy than their male peers, and we've found this to be true too. Now, I've mentioned that we have research and data behind all of these facets, so I'm going to show you just one snippet of one study. Okay, there are at least 5 studies behind all of these, but here's a little bit. So here are some answers to computer self-efficacy questions from one study. The first thing to notice is that the females are kind of a third, and a third. So you can see that about a third of the females had high, about a third had medium, and about a third had low. So on the other hand, the males, you can see that most of them, 75% of them, had high computer self-efficacy, and very few had low. So we can see it's a different distribution, but we can also see it's not binned. We don't have all the males over here and all the females over there, okay? All right, so Tim is one of our personas, and his job is to look out for the interests of everybody over here in the high category. I just don't know if my mouse is behaving. There we are. So in terms of high computer self-efficacy, Tim's job is to make things work for that crowd, whether they be male or female. And the Pats, these are my 2 Pat personas. They're identical twins, a male and a female, and their job is to look out for the people in the middle. And Abby's job, who you've just met, is to look out for the third of the females and the 6% of the males that have low computer self-efficacy. Okay, so let me show you how this panned out in people actually using software. This is one study that we did a while back. This was on spreadsheets. And so we took spreadsheet features and we divided them into 3 piles. The familiar pile, which is formula edits. Everybody who's used a spreadsheet knows how to do that. In our spreadsheet, we had our own research prototype, and so you can see that it looks a little different than, like, say, for example, in Excel, but it's just a text box, and all our people were experienced spreadsheet users, and they do know how to use text boxes. So that was that. Then we had a type called taught. It was check marks and arrows with colors. We knew they had never seen this feature before because it existed only in our prototype. So we taught everybody how to do those in our study. And then the last type, and by the way, what you use those for is if you noticed a value was correct, you could check it off, and it made some colors change and helped you keep track of what parts of the spreadsheets were working and what parts weren't. Then there was one more feature which we did not teach. That was an X mark. And so that was, if they happened to notice a value was wrong, they could X it out. And it caused the system to do some reasoning about where the error probably was. Now, we did not explain that to them. We just said, oh, and there's some X. You know, maybe you'll use it, who knows. So we did not give them any explanation about that. But everything was supported by tooltips so they could discover it if they wanted to. All right, so what happened as a result of this study? Since we're in this for self-efficacy, let's look at that part first. And so what we did is we looked at self-efficacy as a predictor of effective use. And so this is trying to decide, does this self-efficacy actually play out with software? And the answer is yes. First of all, just like all the other studies, in our study, females did have lower computer self-efficacy statistically than males. And so you can see that in the graph. Boy, these colors are weird. The yellow dots are the females, and the black dots are the males, and then the trend lines show the trend, and the pink line is statistically significant, the blue one isn't. Anyway, so if you were to draw, I'm just going to go over there. If you were to draw a line right down the middle of this thing, one thing you'd notice is that most of the females are to the left of the line. This x-axis is self-efficacy. And so that's saying, okay, just like the study says, most of the females are over on that side. And most of the black dots are over on the right side, okay? All right, good. And then the next thing to notice is for the females, there's this kind of nice little 45-degree line that shows that the higher their computer self-efficacy, the more effective they were with the fancy new features. And so what this says is self-efficacy really mattered to the females because it was really predictive of their ability to use these fancy new features. Okay, and it's a problem because most of them were on the low side of the self-efficacy and therefore on the low side of the effective new features. For the males, however, there was no relationship whatsoever. So what this says is you have confident females and you have unconfident females, and it really matters to their effective use of fancy new features. And it says you have confident males and you have unconfident males. And it makes no difference whatsoever as to whether or not they're going to be effective. Some of the confident ones are, some of the unconfident ones aren't. Sometimes it's the other way around. No relationship. So what does that tell us? It says that computer self-efficacy is playing out differently for the two genders, and that we can't say that whatever lack of inclusiveness that's going on is all about computer self-efficacy. What about their interest in new features? Well, I have a bazillion different graphs that show you that statistically, females were less interested in the fancy new features. And so this goes in line with what we saw about the self-efficacy. The time to first usage, the males used it sooner. Genuine engagement, the females like to use the familiar features, the edits, and the males like to use the fancy new features. And so I've got this like 3 or 4 different ways. Now what they'd been told to do was fix the errors in the spreadsheet. So how'd they do with that? We had stuck some errors in that we'd harvested from other end users in the past. And as you can see, there was no difference in the males and females' ability to fix the errors. So what we can see here is there's no intellectual problem going on here, okay? We're seeing differences in approaches, differences in attitudes, okay? But not differences in ability. But look over here. New bugs introduced. So this was errors that people inserted into the formulas that never made it out again. And so the females inserted a lot more than the males. So what's going on here? They can fix just as many as the males, but yet they're inserting more? Why? So to answer this, we need little cat B, facet number 2. Anybody in here know the Cat in the Hat? No. Okay. Sometimes I give this to a foreign audience, and the little cat B thing absolutely does not work. Maybe it doesn't work here either. Anyway, okay, risk aversion. Abby's risk averse with new software features. Now, in the case of our Abby, we know that she has low computer self-efficacy too, and so these two things are probably feeding off of each other. But sometimes risk aversion has nothing to do with confidence. Sometimes it's a matter of time just being valuable. And so Abby does not want to waste time on them and not get any benefits. Okay? So let's just look at a little data just to convince you there is some. And so here, this is from an entirely different source. And so in that source, 42% of the males, almost half, were much more risk tolerant, and so on and so forth. So the first thing I really want you to notice about this one is look at all of these similarities. I've just highlighted it. I'll do it again. Okay? So that shows there's a lot of overlap between males and females. This, again, is not about binning genders. But there are also big differences in the distributions. And so that says we do need to pay attention to these differences and do something about them. Okay, so here's Tim. His job here is to safeguard the interests of all of these risk-tolerant people. And here's Abby. Her job is to look out for the interests of all these risk-averse people. And here are the Pats, whose job is to look out for people in the middle. Now I'm going to stick a big black line up there. There's my big black line. So all the people to the left, that's Tim. The big black line is kind of fighting with these other lines, isn't it? There it is right there. Anyway, over here, okay, that's roughly almost 50% of the males. And so if the people developing the software, we're assuming that kind of attitude. And as it happens, a lot of male software developers are a bit risk tolerant, okay? Then what we're doing is we are supporting about half of the males of the software population and about a quarter of the females, okay? That's why inclusiveness is not only about inclusiveness, but it also is particularly relevant to gender. Okay, so getting back to the question we raised, what about these females that fix just as many of the bugs as the males but introduce more bugs? Well, we know that the females were statistically more risk-averse than the males in our study. We know they used fewer features. We know that females statistically are more risk-averse, and so we were lucky. In this study, we asked a question at the end. It said, if you didn't use feature such and such, why not? And the females were statistically more likely to say, because I thought it would take me too long to learn them. Okay? This is risk aversion. They're talking about time. They're talking about, I thought it would take me too long. But we also did a comprehension test at the end. And we didn't let them look at the system either. And the comprehension test was hard. And they had to explain how the different features interacted and what happens in this snaky situation and what's going to happen in that situation. And there was no difference in the learning, which is kind of flat out amazing because the men practiced those features a lot more, right? I mean, they were actually using them, okay? And still, no difference in comprehension. And the thing is, using the fancy features is actually the safest thing you can do because there's only one way to enter an error into a spreadsheet. And what way is that? You got to edit the formula. And that was the feature that the females were using the most, primarily due to risk aversion and, well, not primarily, due in part to risk aversion and low computer self-efficacy. Okay? So basically, so by the laws of probability, of course, they were adding more bugs. Okay? They're using the most dangerous feature. Okay, so let's turn our attention to differences in learning style. Facet number 3, ways of learning technology. So a lot of software is written with, around the premise that the way people will learn new stuff in the software, new features, is by tinkering with them. But Abby, that's not her best learning style for learning new technology. She prefers process-oriented learning. Things like tutorials, wizards, YouTube videos, a process like you're on step 1 of 5. All of these things are better learning devices for her than unstructured tinkering. So we did another study, and we looked at females and males tinkering in order to learn fancy new features. the females did tinker less. They, of course, as I've just mentioned, tend to prefer other ways of learning technology features. But when they did, they were good at it, okay? There's this kind of tinkering that's called well, it's not called anything, but we called it pauseful tinkering. And so what that means is there was a pause right in the middle of the tink. So a pauseful tinkering looks like this. Tink, tink, okay? So we know from the education literature that when you're in a situation of rapid feedback in which you're trying to learn stuff, that a brief pause makes a huge difference in people's ability to learn from that interaction. And so the education literature has done a lot of work in this, and they have shown that 3 seconds is a reasonable threshold to be using to find this difference. And so that's the one that we used in our study. And in our study, that indeed turned out to be very predictive, whether or not a pause was there, of people profiting from their tinkering, learning how to do stuff. Now, the males tinkered a lot more than the females, and some of them also did it in this mindful, pauseful way. And so in that way, the two Pats are identical, and they look out for the interests of people who do that. But some of the males, I'm sorry, they went a little bit crazy, and when they did, it hurt. And that's what Tim represents. So Tim is subject to tinkering addiction, okay? He can't stop fiddling with stuff, okay? So that's Tim, and the Tims in our study exactly ran into trouble, lost their sort of sense of direction of what they were trying to get done, got very distracted, and so it really got in the way of them learning or doing anything else productive. So here's a gender difference that in software that's actually more detrimental to the males statistically than to the females. Okay, facet number 4. Why is Abby sitting in her chair in the first place? So what's causing her to be interested in using technology? Well, Abby's motivation is she's doing it because she wants to achieve her goals. Okay, so there's some goal like balance my budget or whatever that caused her to sit down and start doing whatever she's doing. She'll learn technologies if and when she needs to get that goal done. But she's not really interested in learning technology just to learn technology. Okay, she has other goals. Let me show you what this looked like in one of the females in our study, in one of our studies. In this one, we were working on a feature called guards. And so this woman, who, by the way, does not look like the picture, said, so 0 to 100 is the guard I'm entering. Okay. So it doesn't like the -5. They can get a 0. And so she's being very businesslike, very goal-directed, right on task. Here's what it looked like for the male. He starts out the same way. The first thing I'm going to do is go through and check the guards for everything, just to make sure none of the entered values are above or below any of the ranges specified. So homework 1, actually, I'm going to put guards on everything because I feel like it. I don't even know if this is really necessary, but it's fun. It's fun, okay? But look, he gets the same benefits out of it that the female did eventually. He says, okay, it doesn't like my guard apparently. Okay, aha. The reason I couldn't get the guard. So they both started at the same place. They both ended at the same place. But their paths for getting there were very different, okay? We did actually, we didn't do this survey. We got access to this survey, which has 100 bazillion questions all about motivation, like, why are you sitting in the chair using the technology? And we found these gender differences in just everywhere in that study. And so you can see, once again, we don't have yeses and nos, and we do have a lot of overlap. So over here, in this particular graph, I only learn technology I have to know for my task. We can see that the females are neutral, okay, and above and below, pretty evenly distributed. The males, no, they mostly disagree. They tend to learn it for its own sake. And you can see there's a lot of overlap, but also some differences. And we have lots of graphs that look like that. This is one by job title. It says the same thing. Here's another one with a different question, says the same thing. Here's another one with a different question, says the same thing, and yet another one with a different question that says the same thing. So this is not specific to some question or some study or whatever. Okay, facet number 5. This is the last of the 5 problem-solving facets. And this is another problem-solving technique, information processing style. So a lot of times when you have a problem to solve, you feel like you need more information, okay? And so you have to go about gathering it. And Abby likes to gather it comprehensively. So here's the difference between Abby and Tim. And this is, again, a statistical difference, obviously not an everyone difference. So Abby likes to gather everything in batches. So it's like gather, 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 gather. Okay, now I know what I'm doing. Act upon it in a series of actions. And Tim is much more incremental. Gather a tiny little bit, do something. Oh, maybe I made a mistake. Back up, gather a little more, and like that. Here's what it looked like in a sense-making study we did. Oh my gosh, she's giving me this graph. Okay, hold on. You don't have to figure this out. I'll just show you the important bits. At the top is a male. At the bottom is a female, just one. First thing I want you to notice is where I've just put those 2 black arrows. So at the bottom 3 lines of this, the bottom 3 rows are where information gets gathered, and the top 3 are where you do something about it. And so what I want you to notice in these arrows is this is the maximum amount of time, about 5 minutes, that he spent gathering information before he acted on it, okay? Other than that, it's really tightly interwoven. Gather a little, do something, gather a little, do something, gather a little, do something, like that. Okay? 5 minutes was his maximum. Now, let's look at hers. Those arrows show that her minimum amount of time, okay, gathering, was greater than his maximum. So it's a very different style. She gathers, 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 and then she does a flurry of activity, like that. Okay, so how successful were they? Well, let's look at the mistakes. So the filled-in stars are successful things, and the hollow stars that I've just stuck red boxes around, those are mistakes. You can see that this male made a lot of mistakes, okay? But he expected to. It's his style. He gathers a little. If he makes a mistake, he backtracks, okay? Let's look at all her mistakes. I've got those all highlighted in red, too. Oh, look, there aren't any, okay? It's characteristic of this style that you don't tend to make mistakes, okay? Both of these have advantages and disadvantages. They're just different. Turns out most software is designed around information gathering of the highly incremental style. So now you know this and I know this. GenderMag is to let the software industry, people like John, know this and make use of it so that his medical technicians' software can be more gender inclusive and his company can actually survive. I'm going to skip the rest of Abby. It's just, pretty much the same as Tim and the Pats. And I'm going to show you the process. So what you do is you come up with a path. A use case is what we computer scientists sometimes call it, through your software. And then you answer these questions. So suppose you say, okay, the first thing we want Abby to do is have a sub-goal to figure out how her budget is different from last year. And so we ask, will Abby, or if you're using Pat or Tim, you say, will Tim have formed this sub-goal? And then when you answer it, it's not only yes or no, it's also maybe, because this is about inclusive thinking. And so when you're doing the process, everyone in the room gets an opinion. You don't have to argue it out. It's not a matter of the strongest voice in the room winning. Every opinion counts. You just gather it up. And finally, you have to say why. And this is where the facets come in. So one example was somebody said Abby wouldn't know what to do on a certain action because of her tinkering facet, her way of learning technology. She wouldn't have pushed and poked around to figure out what that thing did, okay? And so disinclined to push and poke is an exact quote from that participant finding something. So does this thing even work? Yes, we think it does. In fact, we think pretty resoundingly that it does. We've been doing a lot of both formative and summative empirical work, and so we've done some studies, including a field study, and our results are that it's usable by usability practitioners with no gender background and by software developers with no gender background. In fact, even you, if you have no gender background, even if you do have gender background, you can use this. I want to tell you a little bit about a field study we did. All I really want you to notice about this chart is that we had a lot of different kinds of software with a lot of different kinds of companies and a lot of different kinds of people sitting in the room. And here's what we found. These people were evaluating their own software. And the parts in the blue bars, those numbers there, that's how many of their features they found gender inclusiveness problems with. They're doing their own software. They're doing the evaluation. Look, the average was 25%, 1 out of 4 of these features in real software, okay? And they're evaluating, not me. So what is a gender inclusiveness issue anyway? Well, we defined it as something that had to do with the facet values. So if they said it's because of her tinkering or her learning style, it's because of her risk aversion, then what that says is it's going to disproportionately affect the Abbeys of the world. Or if they use Tim, then the Tims of the world. So that's what made a feature not just a generic usability feature, but a gender inclusiveness issue. So let's just look at how it went for some of these agencies. Here's Agency G. They had 2 teams, Team GB and GS. GB, you can see, they were fairly low, that only a mere 14% of the features they found had gender inclusiveness issues. And at first, at the end of the thing, they said, okay, ho-hum, that was fun, bye. And then they reported back to the boss. And the boss said, I've seen that issue among our operators. And this was tremendously convincing to this team. They suddenly realized that the things that they had kind of thought was maybe an academic exercise really mattered. And they talked to Team GS, which is a different agent or a different team in the same agency located in a different city. And GS was already excited, and this got them even more excited. And so they ran it too on a different use case through the same software, actually. You can see they came up with a lot more gender inclusiveness issues. They all, both Team GB and GS, made very good use of the facets. And the great thing is they really get it, that it's not about gender binning, it's about the facets. It's about being inclusiveness. And so, or inclusive, here's an exact quote. It wasn't necessarily about the gender, it's facet values. Here's Company E, a completely different company. And they too, they got very excited, and they realized by the time they were done too, that it's all about diversity, not about gender binning. And so they too said, is it about gender or is it people differences? It revealed things they'd never noticed, and they said it makes it easy to detect those things. And 2 weeks later, when we checked back with them, they'd already fixed 3 of the gender inclusiveness issues that they found. Company W, so I'm just giving you little snippets of these people because we don't have time for all the rich results that we had. But Company W, we checked back after a few weeks, and for Company W, this was hard because it turned out the things they found they didn't own. And so they found it, and then they had to convince the decision makers, the ones who would actually do the work, that these things were actually gender inclusiveness issues. Those people never even heard of the concept. They're going, you're kidding, really? But Team W believed, and they persisted, and they got those important issues fixed. After 5 months, they were still using it. It had spread a bit into spin-off groups and related labs, and one of the messages we got back from them is, Abby lives on in the X lab. 10 months later, they started exploring wider long-term usage. We're at the very, very, very beginnings of that, so we hope something great comes of that. So to kind of summarize everything I've talked about, we can see that there are promising results coming out of this, but there's a lot to do to help the software industry and the world understand that gender inclusiveness rests not on gender bucketing, but rather on supporting diverse ways of thinking and problem solving so we can get rid of this ugly red X. Here's a quote I really like, one way of putting it. This is by Ashcraft and Dubois. They said, "Women in technology do not generally need extra help, but the software in which they work does need help." So, in summary, the goal of this work is more gender-inclusive software, one facet at a time. So that's it. I'm open for questions, and also if anybody is interested in resources and stuff, you can take a picture of this slide, and then I'll go back to that other slide. Okay, I don't see anybody taking pictures, so oh, you are taking pictures. Okay, I'll just be patient here. Yes, go ahead and ask your question.
How unique do you think this set of problems is to software? Is there something special about software that makes this unusually difficult for software people?
It's a very good question. For software people or for software as a product? Well, let's answer it both ways. So for software people, I think that perhaps there's, I don't know. We've investigated this in software, but I don't think that there's anything that says that it shouldn't work in, say, for example, let's go with a closely related product like hardware, okay? And then let's say, well, how much farther out can we go? How about processes? How about education? Can we use some of this? And so, it's clear to me that we can definitely use some of it to inform our thinking in all of these venues. But whether we can use this process and these specific facets as we wander farther and farther afield from software, that would still require lots more research to really figure out how to do it. I know a few people that are interested in doing it, but it would be awesome to actually investigate that. Let's see, that was software as a product. Software people, I don't know. Go ahead, Carlos.
Thank you for the talk. It was wonderful. So you showed 5 facets, and for each of these facets, there's at least 2 possible positions that people can be in. So how do you go from that combinatory mess to 4 personas? Is it that there's a whole bunch of these combinations where there are no people, or how did you strategically choose to kind of limit the design space, which is very important?
Mm-hmm. Yeah, thank you. That's a great question. You're right. We could have come up with a whole lot of personas, but in the software industry or in any industry that uses personas, there's a limit to how much, how big your tool set can be. And so what we did is we started with the features, the facets that are statistically really common in males. And so that became TIM, the sort of most extreme values that are really, really common in males. And then for Abby, we took really common features for females that are as far away from the TIMs. So they aren't necessarily majority features, but they're really quite common features for females. And we did this to get the 2 endpoints of the facet values. And then for the PATs, they aren't always exactly the middle values, because some of these things aren't really a spectrum from like 0 to 1. Some of them are multi-valued possibilities, like the style of learning technology. So the PATs represent different values than the TIMs and the ABBYs, or sometimes they combine a few values of the TIMs and the ABBYs in order to cover a place somewhat different in the space than either TIM or ABBY would do. But I've come to believe over the studies that I've been doing that TIM and ABBY and the PATs are not really very static. That a lot of times people become situational ABBYs where maybe, or situational TIMs where maybe their normal state is sort of something like a PAT. So one example might be you might have a TIM who is very technology confident and very risk tolerant and lots of other stuff like that. And tinkering oriented, and then let's say what he's doing is he's working on the last stages of software that's about to be inserted into a medical device that's about to be hooked up to a patient. Okay, so suddenly he's really risk averse And if he doesn't know the medical domain very well, he's probably really low self-efficacy, and a lot of other things are probably really different. And so what that says is, you know, these personas can be used for these situational setups as well. And in fact, it reminds me of something recent that I saw that really impressed me. It was an inclusive design team in a company, and so what they pointed out is if you're designing a product, let's say a software hardware product for a person with one arm, you're also designing for a parent who's carrying a baby or a person whose arm is temporarily broken, or you know, just a lot of other situations. And then they have similar analogies of, say, for example, if you're doing a product for somebody who has vision impairments, you're also doing that product for somebody who's trying to see in glaring light outside, or not enough light, or you know, when their eyes are dilated, and lots of other things like that.
Very great talk. I really like the work.
Thank you.
I'm Anita Sarma from EECS, and my question is, you had to pick 5 facets, and you're talking about GDP across India and other places. Could you give a few thoughts about how do you see culture affecting these facets, or what's the connection between culture and these facets or other facets?
Okay, great, thank you. So there are a lot of different answers to that. The first answer is the data that's behind these things, although probably the lion's share of it is US-centric. Certainly not all of it is US-centric, and in fact, I've seen very similar studies come out of Europe and Asia. So it's not restricted to the US, but there probably are some differences, even so, among different cultures. One student of one of my collaborators a while ago looked to see how these things differed in the US versus Thailand, and she did find some differences. And I think it would be really interesting to look at it that way. Yet another way of thinking about it is, what if we just don't think about gender, and instead we just look at cultural differences, basically the country you live in. And that's valid too. And in fact, there are a lot of different ways you can slice the diversity question you're looking at. You could divide it by age and say, well, let's look at young people versus middle people versus old people, and all kinds of things like that. The only thing is, the facets that are behind this were all researched in terms of gender differences. And so, although some of them probably apply to other situations, they may not be the most important, or even have important differences in some of the other ways of slicing the population. So somebody would have to go back to the foundations to see which were the most important facet values to bring forward if you wanted to slice it in that different way. I probably answered a lot more than you really asked, but.
I have a historical question. So the first women programmers for ENIAC project, has anybody looked at how they coded? Because they were the first. Has there been a study of those ladies?
That's an interesting question. I don't know that anybody looked at their style of coding. I don't even know if anybody looks at males versus female style of coding right now. I haven't. I've looked at their ways of dealing with problems and problem solving in general, but when it comes right down to the way their coding looks, or the order in which they do things, I haven't looked at that either. If we wanted to take a historical view, it would be really hard, because the languages have changed so much. And so that would be really challenging, but really interesting. Yeah. Any more questions? Okay, then, I guess we're done.